so this is my presentation. Can you guys see my screen?
Yes.
Okay, so this is my presentation. Linguistic knowledge in data augmentation for natural language processing.
Can you make it full
it's
screen,
based on
please? Can you make it full screen?
Sorry.
Yes, yes.
So it's just give me a second. So it's example based on Chinese question matching. So background knowledge, data augmentation. We know data augmentation is a common strategy to generate novel label preserving, but label preserving data to remedy the data scarcity and imbalance problems. For for computer vision, people can simply do some rotations or add some noises or other techniques to generate new images, but have the same labels. In the field of natural language processing, data augmentation is also known as text augmentation. And there are several proposals made in this field to augment text, such as token level text editing, back translation, or neural network model-based predictive text transformation. But unlike computer vision or speech recognition, the augmenting text is much more challenging. That's because the nature of language is different than the nature of image or speech. And so that's why it's very hard to have universal and very effective text augmentation techniques for natural language processing. So the problem is there is no strictly paraphrastic text augmentation techniques. And augment text is usually very low quality, ungrammatical, even meaningless. So here are examples. So this is the original sentence: a sad, superior human comedy played out on the back roads of life. And SR stands for synonym replacement. So even synonym replacement based on a dictionary will be nonsense. The human is replaced by harmon, and comedy is replaced by funniness. And this is render insertion. Randomly insert some synonyms into this sentence, which makes this sentence again ungrammatical. So we don't have very good augmentation techniques. My question related to this is my question: what is the role of linguistic knowledge in data augmentation? If we add some linguistic knowledge to some data augmentation techniques, what's the role? Will that help the quality of the augmented text? So my hypothesis is that if we add some linguistic knowledge to these data augmentation techniques, maybe that will produce some higher quality augmented text, and that probably will be more label preserving, because the whole point of data augmentation is to produce novel and label preserving new data, and that might improve the performance of the trained model on certain tasks. So to evaluate that, unlike previous study that commonly evaluate the performance of data augmentation on some simple tasks, such as sentence classification task, sentiment analysis tasks, where a few keywords can often determine the label of the sentence. I decided to go with text pair classification task, or more specific, text matching task. That's because for text pair classification task, the label is determined by a pair of sentences. So to predict whether two sentences are of some label, the model must need to be able to differentiate some very tiny semantic differences or similarities between these sentences in order to predict the true label. And since we know data augmentation cannot produce paraphrastic sentences strictly, that will show whether those sentences are label preserving, whether the techniques are useful. So I evaluate my hypothesis on large-scale Chinese question matching corpus. It's a question matching corpus. So it's of a decent size. So every example consists of 2 sentences and a label to indicate whether these 2 sentences are, express the same intent or not. And so this is the task and the data set. And the augmentation methods I used is called REDA, Revised Easy Data Augmentation program, which is based on inspired by a program called Easy Data Augmentation. It consists of 5 token level text editing operations: synonym replacement, random insertion, random swap, random deletion, and the random mix. The reason why I use this simple token level editing operation is because they are simple. It has been shown by this author that these techniques are could be universal. So I also would like to evaluate that whether these token level editing operations are universal or not. And because it's easy, it's also very straightforward and more interpretable compared to other methods like back translation or other neural network based methods. So in order to make sure that the techniques, the augmentation does work, typically this augmentation usually only work when the text editing rate is small. And I also ensure that my program does not produce duplicated augment text in order to diversify the training examples. And for many experiments, this is the size of the augment text. Usually it's like 10 times more than the original example provided to the program. And here are the statistics for the ablation study, which we'll cover later, where each text editing operation is applied to the train set of the large Chinese scale question margin corpus. So in order to infuse linguistic knowledge to the data augmentation techniques, I trained a n-gram language model up to 4 gram based on the large compiled corpus of Chinese, which consists of 6-something million words. It's 6 million something words. It's not just 600 words. And the objective for this network n-gram language model is to maximize the mass likelihood of this function. And the reason why I choose n-gram over neural network language model is because it's more efficient to train to begin with. And this program n-gram model is totally frequency based and is more interpretable than neural network language models, just to make the experiment simple and the results more interpretable. So the effects of we can also evaluate whether n-gram language model does improve the quality of the augment text by some simple text restoration tasks, such as the following. So I perform some text added to for some examples, for some 10,000 examples, and then apply synonym replacement, random swap, random deletion with these 2 programs, REDA and then REDA augmented with n-gram model. And it turned out that the augmentation with n-gram model outperforms models that without n-gram model. So that means the N-gram model does help generating higher quality augmented text. And classification models. I trained the following 5 models on this data set, and to evaluate whether the augmentation helps the augmentation with N-gram models does help training a better model. So here are the hyperparameters. And let's see the results. And this is the results for the main experiments. I trained the baseline model trained on the original corpus without augmentation as the baselines. As can be seen from this table, it turns out that the model trained on augmented text does not even outperform the baseline model for both augmentation methods, with or without N-gram length model. As you can see in the first 2 columns, the performance is always the best when only the original examples are used. That means the baseline models are the best. The models trained on the augmented text only outperform the baseline models when enough examples are seen. Let's see when there are at least 50,000 original examples are provided to be augmented, as can be seen in this table. And not surprisingly, the best performance are always achieved by this pre-trained model, but still the pattern remain. When the training examples are not sufficient, the best performance by the baseline model instead of the models trained on augmented text. And there appears to be no difference, even very slightly negative effects of models trained on data with N-gram augmentation. So here's so the summary: model augmented with radar failed to surpass enhanced by the N-gram model failed to surpass radar-related counterparts, and model with both augmentation methods only surpass the baseline models when enough examples are seen. And here are some other metrics: the precision, recall, and the F1 score. But please note that since the corpus is label balanced, so accuracy score is enough to differentiate the differences between the results. As can be seen, the model trained on different types of train sets. This is the baseline. This is radar, only those 5 token level text editing operation, and then enhanced with N-gram model. It can be seen that the model trained on examples enhanced by radar, it has better recall score than model trained on baseline. That means maybe when enough examples are seen, the model are enabled to mitigate the negative effects of false matching text and able to turn that into sort of regularization, and then outperform the baseline model. Also to confirm that, to validate that, also the conduct ablation studies, ablation experiments, only applying each single text editing operation. But it turns out that the pattern remains. The model trained on augmented text only outperform the baseline model when enough examples are seen. And in this case, it appears to be somewhere near 1,100 examples, which might be has to do with the separation of these techniques. And the pattern we observed between radar and radar enhanced by N-gram model still remains here. And to explain this, I also plot the results on precision score. And it can be seen that there is a strong correlation between the precision score and the accuracy. Again, that might mean that the model are only able to mitigate the negative effects of augmented text when enough examples are seen. That improves the precision score. And here is the recall score. There is no pattern correlation between recall and the accuracy or precision. So so the observations are twofold. On one hand, models trained with radar enhanced by on-ground augmentation did not surpass those with radar augmentation in the text performance. In terms of the text performance, both like accuracy, precision, recall, and F1 score. And there's a restriction on the size of the data. Models trained with both augmentation methods fail to surpass the baseline model unless enough amount of original examples are seen. So that might mean linguistic knowledge it's not like very helpful when random text editing perturbations the augmentation techniques used in this study are concerned. That's because random text perturbation, as I mentioned in the very beginning, are unable to generate strictly peripheristic augmented text. And the added linguistic knowledge does improve the quality of the augmented text, but that does not preserve labels as well. And regarding the restriction on the data size, that means both augmentation methods are prone to producing false matching examples. And enough examples are not needed to negative in order for the models to mitigate the negative effects. So the side implication that random text editing perturbations are not claimed to be universal. They are not universal. They have limitations. I also conducted a postdoc experiments on English, but due to time constraint, I will just pass that. The basic patterns remain valid even for English, although the threshold, the outperformance threshold is different. This study also has limitations, such as I'm unable to do very extensive experiments constrained by the available resources, and future works might be able to fill this research gap, and then my re-examine the effectiveness and limitation of these text editing operations. Thank you. This is about my presentation, and I'm ready for any questions. Thank you.